If supply chains stopped today, this food would keep you alive for years. No refrigeration, no technology, no system, yet it's officially classified as emergency food. That classification is the lie. It stores for years. It feeds armies. It requires almost nothing. So why did it disappear from modern food systems? A single tree produces enough protein to sustain a family for a year. It requires almost no water. It grows in soil where nothing else survives. And modern agriculture classifies it as ornamental. That reclassification was not accidental. What pharaohs preserved in sealed chambers, what Vedic physicians cataloged as the tree that cures 300 diseases, what Roman merchants paid fortunes to import, now grows wild along roadsides and is harvested by no one. The moringa tree was not discovered by contemporary nutrition science. It was buried by an economic system that could not profit from something that grows without patents, without fertilizers, without dependence. This is not about health trends. This is about how survival technology gets erased when it threatens the structures that control food. Ancient Egypt did not call moringa ornamental. Tomb inscriptions from the 18th dynasty document moringa oil, called ben oil, stored in alabaster vessels alongside grain reserves and placed in burial chambers as essential for the afterlife. Archaeologists excavating workers' villages near the pyramids found moringa seeds in food storage areas, not gardens. The tree was not decorative, it was infrastructure. Pharaonic medical texts prescribed moringa for infections, inflammation, and digestive disorders, listing preparation methods with the precision reserved for weapons and engineering. The oil pressed from moringa seeds does not spoil. Egyptian perfume makers used it as a base because it remained stable for decades. That stability was not luxury, it was preservation technology in a civilization dependent on stored resources. When Roman traders established routes into Nubia and Upper Egypt, they paid premium prices for moringa oil, not for cosmetics, but because it represented the only plant-based oil that could survive transport across the Mediterranean without rancidity. The economic value was rooted in survival capacity, not scarcity. Vedic texts refer to moringa as shigru, the tree whose every part has function. Sanskrit medical manuscripts from the Maurya Empire, dated to the 3rd century BCE, categorize moringa leaves as a famine food capable of sustaining populations when grain crops failed. The classification was not metaphorical. Ayurvedic physicians documented moringa's use during prolonged droughts in the Deccan Plateau, where monsoon failures made conventional agriculture impossible. The tree's deep taproot, reaching down 20 feet, accessed water unavailable to surface crops. Its leaves could be harvested continuously without killing the plant. Ancient agronomists recognized this as a hedge against systemic collapse. When grain stores depleted, moringa remained. The Artha Shastra, a treatise on statecraft from the same period, includes moringa cultivation and guidelines for famine preparedness, listing it alongside water management and grain reserves. The prescription was administrative, not spiritual. Empires that maintained moringa groves survived crises that destroyed those dependent solely on annual crops. Moringa trees require no irrigation after establishment. They grow in soil with pH levels between 5 and 9, tolerating alkalinity and acidity that kills staple grains. A single tree reaches maturity in 8 months. Within 2 years, it produces seed pods continuously for up to 40 years. Each tree yields approximately 400 pods per year. Each pod contains an average of 20 seeds. The seeds produce oil at a rate of 38% by weight, one of the highest oil yields of any plant. The oil requires no refinement to remain edible. It does not oxidize under normal storage conditions, maintaining nutritional value and flavor for up to 5 years without refrigeration. The leaves contain 9 essential amino acids, making moringa one of the few plant sources with a complete protein profile comparable to animal products. 100 grams of dried moringa leaves provide 27 grams of protein, more than double the protein content of milk by weight. The leaves also contain 7 times the vitamin C of oranges, 4 times the calcium of milk, 4 times the vitamin A of carrots, and 3 times the potassium of bananas. These are not approximations. These are measurements replicated in laboratory analysis across multiple studies. The logistical implication is that a single acre of moringa trees produces more nutritional density per square meter than any conventional crop system, requires no external inputs, and continues producing for decades. The 1943 Bengal famine killed an estimated 3 million people under British colonial administration. Grain exports from India to support Allied war efforts continued even as rural populations starved. District records from Bengal show that regions with established moringa cultivation, particularly in areas where pre-colonial land use had not been fully converted to cash crop monoculture, experienced significantly lower mortality rates. Villages in Midnapore and Bankura, where moringa trees grew in household compounds, recorded survival through a period when rice and wheat were unavailable. The British Famine Inquiry Commission, published in 1945, documented these regional disparities but attributed them to vague cultural factors rather than food infrastructure. The report did not analyze why certain villages survived. It did not investigate which foods replaced grain. That omission was structural. Acknowledging that a tree growing outside the colonial agricultural system provided better famine security than the export-driven rice economy would have undermined the entire logic of imperial resource extraction. The people who survived did so by consuming moringa leaves as a primary food source, supplemented by seed oil and root vegetables from the same tree. The system that caused the famine could not admit that the solution had existed outside its control the entire time. A kilogram of beef requires 15,000 liters of water to produce. A kilogram of moringa leaves requires 0 liters after the tree is established. Beef production generates 27 kilograms of carbon dioxide equivalent per kilogram. Moringa trees sequester carbon. 1 hectare of moringa plantation removes approximately 50 tons of carbon dioxide annually. Beef requires 16 kilograms of grain feed to produce 1 kilogram of meat. Moringa requires no feed, no fertilizer, no pesticides. The economic structure of industrial agriculture subsidizes the former and ignores the latter. In the United States, federal subsidies for corn and soy, which primarily feed livestock, total approximately $20 billion annually. Subsidies for perennial tree crops with equivalent or superior nutrition? 0. The cost of industrial meat includes environmental externalities estimated at over $400 billion per year globally, costs borne by public systems not incorporated into market price. Moringa trees impose no externalities. They improve soil, prevent erosion, and require no chemical inputs. The price signal in modern markets does not reflect nutritional efficiency or environmental cost. It reflects subsidy structures designed to support commodity crops and industrial livestock systems. The question is not why moringa remains marginal. The question is which economic interests benefit from its marginalization. Scientific validation of moringa's nutritional profile did not occur recently. In 1998, the World Health Organization published a detailed analysis confirming what ancient texts had documented. Moringa leaves contain higher concentrations of bioavailable nutrients than any cultivated vegetable. Studies from the National Institutes of Health between 2007 and 2015 demonstrated that moringa extracts reduce inflammation, lower blood sugar levels, and exhibit antimicrobial activity against multiple pathogens. Research published in the Journal of Ethnopharmacology confirmed that moringa seeds purify water, binding to bacteria and sediments, allowing contaminated water to become drinkable without industrial filtration. The mechanism involves proteins in the seeds that act as natural flocculants, the same function ancient Egyptians utilized when they stored moringa in proximity to water supplies. Modern pharmaceutical companies isolated compounds from moringa and attempted to patent derivatives for drug development. The patents failed because the active compounds cannot be synthesized more effectively than they exist in the plant. The pharmaceutical model requires modification, refinement, and exclusivity. Moringa offers none of those entry points. It remains chemically stable, freely reproducible, and impossible to control. The scientific community validated ancestral knowledge, then moved on, because validation without commodification holds no institutional value. Moringa was not the only survival technology reclassified into irrelevance. Amaranth, a primary grain of the Aztec Empire, was banned by Spanish colonizers and later classified as a weed, despite containing more protein than wheat. Breadfruit, cultivated across Polynesia as a staple crop for centuries, was introduced to the Caribbean as slave food and never integrated into Western agriculture, despite producing more calories per acre than rice. Mesquite, a nitrogen-fixing tree that sustained indigenous populations across the southwestern United States, was eradicated by cattle ranchers and classified as invasive, despite producing edible pods with nutritional density comparable to soybeans. The pattern repeats. Each time, a crop that requires no industrial inputs, that grows in marginal conditions, that provides complete nutrition, gets systematically removed from agricultural systems and reclassified in language that removes its economic legitimacy. The reclassification is not botanical, it is economic. Systems that profit from dependence cannot coexist with technologies that provide autonomy. The language of weeds, ornamentals, and minor crops is not scientific taxonomy. It is economic gatekeeping. Climate models project that by 2050, temperature increases and shifting precipitation patterns will render 30% of current agricultural land unsuitable for staple crops. Wheat, rice, and corn, the three crops that provide 60% of global calories, all require stable water inputs and moderate temperatures. Moringa thrives in temperatures up to 48 degrees Celsius. It survives droughts that last 8 months. It grows in degraded soil where industrial crops fail. The regions projected to experience the most severe climate impacts, Sub-Saharan Africa, South Asia, and Central America, are the same regions where moringa already grows wild and remains unharvested because it holds no market value. The coming food crises will not result from a lack of available nutrition. They will result from economic systems that have spent 2 centuries suppressing crops that do not require corporate supply chains. When industrial agriculture collapses under climate pressure, the populations that survive will be those who retain knowledge of perennial food systems. That knowledge was never lost. It was deliberately marginalized. The return to moringa will not be a rediscovery. It will be a forced acknowledgement of what should never have been abandoned. If this vault revealed something they tried to erase, subscribe to preserve what history tried to bury. Knowledge only survives when it is remembered. The next vault opens soon.